Okay, all right. So we import our libraries first. So we're going to import some set of libraries starting with our NumPy. So let's start by importing our NumPy because we'll be doing some mathematical as MP. Then we import our pandas. Import pandas as PD. All right. Let's import our matplotlib. We want to port some plots, some graphs today. So import your matplotlib dot pyplot and call it as a PLT. Let's give it an alias called PLT. Let's also import our seaborn that we can use some other functions on our map, on our plots. So let's give seaborn as a SNS. Let's call it SNS. Then let's import our stats library from scientific pi. So we say from SciPy import stats. We need to do some stats. All right. Let's import our power transformer, one auth encoder and the ordinary encoder. So we'll import that from scikit-learn. So from sklearn dot pre-processing. We are working on advanced pre-processing. So this is beyond what's it called? Beyond just using an input method. So we want to use some power transformers. Okay. Let's use also one auth encoder. Let's use one auth encoder. One auth encoder so that we can convert categorical data into numerical. Then let's also import our ordinal encoder. All right. Then let's use our KNN imputer. So from a scikit-learn impute, I taught you some other ways that you can, apart from using your mean median mode. So your mean median mode, we can we can use our impute. So let's use our dot impute. Let's import our KNN importer. So KNN imputer. All right. Then let's take an isolation forest. Let's use a forest and assemble. I want us to try an assemble model. So let's do from our scikit-learn also. Our scikit-learn dot assemble. Let's use an assemble tree model. All right, let's import what we call the isolation forest. So you see why we are doing all this by the time we are going on. Then lastly, we talked about Windsorizing. You remember when I talked about Windsorizing? So from our SciPy again, let's dot stats dot mstats. Let's import it. Let's import a Windsorizer. Windsor. So let's do Windsorize. All right. So I want us to now do like a print message to say, just create a print message that says what? Libraries imported successfully if you don't have an error. Libraries imported successfully. All right. So if you are here, you can do me a screenshot. But before that, just try running it and be sure that you can actually access all these libraries. Okay. So you can see now it's telling me that what cannot import power transformer because I don't have power transformer. So it's not power transformers. You can see it's complaining. It's not power transformers, it's power transformer. So we need to rerun it again. Ordinal encoder. Ordinal encoder does not have an R. It is ordinal encoder. All right. So until you get this exactly. So now you can see that we are good to go. So can I get a screenshot of this quickly, Joseph? If you have gotten here, can I get a screenshot that you have been able to do this? We have a lot to do this evening, so send me your screenshot as usual. Then we'll carry on from there.
Okay, sir.
Mm.
But I wanted to ask, is
Oh,
there a way to maintain video quality on like a Zoom call? Because everything here is looking a little blurry to me.
you can't, I think it's because of your network. Uh, it's your network. So you can't actually see what I'm doing. What network are you using? Can you see my screen now, Joseph?
Yes, sir. Yes, sir. Yes,
Is it
sir.
is it clearer now?
Yes, sir. Yes, sir. Very much clear.
Thank God. Sorry, a call was coming in. I didn't know, so it was distorting network. So I've turned off the call stuff. Sorry about that. All right. So if you are through with this, the next thing we'll be going into now is we want to create a dummy data set. So let's try and create a dummy data set. So just send me your screenshots. I'll follow up. So after this, so let's use our what's it called again? Our markdown, and say we are creating what? A dummy. So let's create a dummy data set quickly because of our time. So let's do that. So we're going to be creating a dummy data set. So I'm going to be setting a random seed. I need a random seed so that automatically it does its seeding itself. I don't need to give it any what's it called, any value. So I say random seed. Then I call the random seed, give it 42. So let's call it random seed. Then let's generate a right skilled income data. Let's generate a right skilled income data. So I say income equals mp dot random. So you see why we're using the random seed. So dot exponentials. So yeah, we are trying to create what? We are trying to create a random skilled data. So we are creating our dummy data, but we are adding some, we're adding some values into it so that we have some skewed data in it. So by the time we are plotting, then we can plot and see what a right skewed data looks like different from a normal. So let's do it that way. Then just add. Okay, 20,000. All right. Then let's generate a normally distributed age data. So we have already a skewed, so let's do age. We're creating an age data that will look normally distributed. So we're still calling our random seed. It generates it itself. So let's call it normal. Since it's a normal, so let's give it a location. So location is 40. And let's scale. Let's scale it to 10. Then give it a size of 1,000. Let's give it a size of 1,000. All right. Then let's create a categorical level for education. So you can see that this is our columns for our random data that's going to be generated. We're going to view and be sure that we've gotten what we needed. We're going to print the first row. So let's get a random choice. Let's use random.choice. So choice now is that we want to pick what we can use a categorical data. So let's use low, medium, and high. Low, comma, medium. Let's another comma, and let's give it high. All right. Then before this, please go back and put a what? A block bracket here. If not, it won't work. Let's give it a block bracket. Give it a comma. Let's give it a size of 1000 also. So that is generating at 1000. I think network is fluctuating, so don't worry, I'm recording. It's network, the network is fluctuating. Then let's insert missing values. I want to insert missing values. So for age, let me insert some missing values. As long as you can hear me, there's no problem. Just try and follow. I'll pause, then let's just do this so that we can get our data ready because of our time. The choice I told you want to, you can use what we call choice. So let's impute some missing values. So we'll say out of the 1000 data set, let there be about 50 missing values. So we'll close our block bracket. Then we create it to what? Call it mp dot what? Unavailable, non-available. So it's none. Let's do the same thing for income. That's the same thing for income. So we'll say income also the same thing, income. Open your block bracket and say mp dot random dot choice. So we say out of the 1000 data set for it, let 30 be missing also. Let 30 miss. So we say equals to what? mp dot nan. Then lastly, for education, let's do the same thing for education. Let's do the same thing for education. Open our block bracket as usual and call our numpy dot random dot choice again. Then open our bracket and close and say out of the 1000 data set that is created, let 20 be what? Let 20 be missing. So we are trying to create a perfect what? A perfect data that has missing values as well as having skew. So we've done for this, we've created a skew, the first skewed. The second line, we created what? The age to be normally distributed, education having what? Categorical value. Then now we are imputing missing values. Then let's add a bit of outliers. Let's add outliers to the income and age. So I say income. Let's add outliers to income and age. So at this range of income from, let's use the block bracket and say have about something like a 1 million. So I think this will be very good as a good example. So let's give it 1 million. Then let's do for age also. Okay. There you have it. Let's put equals 5. All right. Then let's build our data frame. Let's build a data frame for what we've done and display the first 5 values. So I'll call my data frame df. So that will be pd dot data frame. Open my normal bracket. Okay, you can see the screen now. Thank you. Thank God. That's good. All right. So let's give age, which is in age. call it, okay, say H, all right, comma. Let's do for income. I hope you can meet up with me, comma. Then let's do for education. So just because of our time, that's why I'm not putting comments. So later we'll be adding comments so that you can understand what is happening per line. Okay. So let's close our bracket. First, our curly bracket, our normal bracket. Now let's print the first 5 rows to be sure that it was properly created. So I'll say dummy data set created. So let's give a message that says dummy data set successfully created. Successfully created. Then we now say, okay, on a new row, it's successfully created. Then I'll tell it to print successfully created, full stop. Say, okay, okay, also showing first 5 rows. So I add something called so I'll just add a new line. I'll add a new line showing first 5 rows. Add a new line, comma. Then let's do df dot add. Then you can close your bracket, add a comma. Then you can reference what a new line. Okay, so you are here. So what we've done is that we give a random seed. Our income, we made it what have what you call a skewed data income. For the age, we did a normal distribution. For education, we have made education to what? We created just a categorical data for education. Then added some missing values and inserted some missing value. This is what this is doing. Then added outliers to our income and age. Then now we are creating a data frame. So let's run this. Okay. So you can see that we have this. So it means that yes, what we've done is looking good. It's looking good. So if you don't like the way the format is, you could just rightly change this and change it to display. So if you want to give it a well formatted and say let's call it a display. All right. So you can see. So if you are doing display, then we don't need the new line anymore. All I need to do is clear the new line off and close it and display. So, all right. So you can either use print or display. So you should have something like this now. Okay. So now we are going to the first part of what we spoke about in our class. Let me pause now. Let me pause the recording and see if you can. Let me pause the recording and see if you can screenshot to me. All right. Joseph, can you give me a screenshot?
Okay, so I'm working on that.
Okay, great. So let me wait for you then. 2 minutes, please. Okay. Sorry about that. So let's see what we can do. Okay, so you've seen what I've done now. So while you are doing that, let me add my comments quickly while I wait for you so that for each line, you know what I've done for each line. So for this line here, I told you, you use your hash for what? For your comments. So I've set what? Randomly. I've set randomly seed for what? Reproducibility. So I've told it in this instance, produce, and I've given it the instance of my what? Reproducibility, 42 instances. So you can see that. Then for this line, what did I do here? All I've done is what? I've generated a skewed, we generated what? Generated a skewed income data. Then for age is normally distributed. So we did a normal age distribution. Normal age distribution. For education, we have created a what? Categorical data. So we created categorical data for this. Then for this place here, now everything encompassing here at this code here for the top. So I'll put it at the top for this code. All I've done is what? I've added missing values. To all three below. I've added missing values to all three below. Then for these two here, for this line here, what I've done is what? I've added outliers. So I added outliers to the two below. Then this last code here, what we have done is what? We have created a dummy data set, and what? Viewed the first five, view the first 5 rows. So you can see that this is just so easy. The more you get your hands dirty, the better you begin to understand what is happening. So this is what we have done here. All right. So Joseph, are you still with me?
Yes, sir. Yes, sir.
Almost done?
Yes, sir.
Okay.
About
Okay. So that's great. So if you're done, let's go on. Please, I must see your screenshots. I want to see screenshots of the importing of the libraries and screenshot of what? Creating your dummy datas. These are things that I will use because I will still tell you to create like what's it called? You create like a folder for me, or you attach and send to me. I will send mail. So every screenshot, so it's part of your assignment for when we are working on practicals. I must see screenshots to be sure that what we are following the class. All right, great. Okay, so I can see screenshots now. Libraries, okay, and this. So what are we doing next? Let's pick our markdown. No, this is not a markdown, sorry. We needed a new row. So let's pick a markdown for our new row. What we want to do now, we want to see what? We want to detect skewness. So let's detect skewness. How do we detect skewness? So let's detect skewness. Okay. So how do we detect skewness? I told you there are several ways. Is either you can plot what you call the histogram to see your skewness, or you can use your quartile word plot, your quartile plot. Okay. Then we can also see numerical skewness. So let's do the first one. Let's do the plot. Let's plot an histogram. So let's plot an histogram. So I'll say histogram plot. Let's plot an histogram. Okay. So when you're plotting an histogram, that's why we actually call that library called what? The matplotlib and the cbon, which we have given the matplotlib .py plot. We have called it an alias of what? PLT. So we're given an PLT. So we'll call histogram, which is called hist. In your Python, histogram is called hist. So you open a bracket, put your df, then open a square bracket, add your income. We want to see a skewness from, you remember that we added what to the income area. That's where we added our skew. So, all right. So let's see what is going on. in here. Okay. So then let's give it a title. We always have a title, so let's give it a title. So what should the title be called? Let's call it income distribution. Let's give it income distribution. Income distribution. All right. Then X and Y label, we need to print our X and Y label. So we'll do income and frequency. So let's plot our X label first. So PLT dot X label, you can see it's just as simple as English. So I tell you one of the good things about Python. So we enter for our X label, we want the income. Then for our Y, PLT dot Y label, we want how many times it's occurring. So let's use a frequency. Let's give it a frequency. Okay. Then every time you want to plot, you end with always what? PLT dot show. So when you do that, PLT dot show. Then let's print our histogram and see what will happen. Let's print and say histogram displayed. Let's be sure that our histogram is displayed. And let's give you a message so that you're sure if your histogram is displayed, you should see it. If it's not, then it means that histogram displayed. Displayed. Okay, so let's run this first. Okay, it says something is unmatched. What did I do wrong? Okay, you can see I added two brackets. So when I added two brackets. Okay, so what is missing? DF income. What did I do? All right, income. Always remember strings. Strings must carry what? Must carry what? Your quotation mark, either your single or what? Your double quotation mark. Okay. All right, so something else I've done again wrong. Not bean, it's supposed to be beans. It's B-I-N-S. B-I-N-S. Okay. All right. So can you see my histogram? So can you see that is what? Is skewed to the right. You've told us when it goes this way. When I was showing you, can you see? It's coming this way. It's skewed what? To the right, because that was what we created. So you should have something like this now and be able to give me a screenshot of this. So this is our detecting skewness. We've been able to detect skewness. So you can see, so you should have a graph like this also. It says histogram displayed. All right, I'll give you about 2 minutes to catch up so that you can send me the screenshot then. We'll now use and see, okay, how does the QQ plot to visualize deviation from the normal distribution. Now we know that this is showing us that what? It is skewed to the right, which is there's a deviation. So we want to use our quarter plot to know, okay, what is the level of deviation from the normal distribution. Okay, waiting for you, Joseph. All right. So So we can move on this way. Joseph, are you done? I need your response. You may have to give me some time again. I don't know what's okay. Your network, all right. So maybe you watch the video. Like I've said earlier on, uh, you must show me a screenshot of this for me to be sure that everybody must have done this and sent me what? Sent me screenshot. So we'll be able to detect skewness using our histogram. So let's go to the QQ, the quarter plot, which I call the QQ plot. So we'll call this cell a markdown cell. So we'll do our QQ plot. And like I told you, our QQ plot is used to check what? Deviation from what? Normal distribution. Normal distribution, if you have been able to go through the notes. So let's quickly do that. Use what you call stats. If you remember, we called a library called stats. And this is more of a probability plot. So you see we're plotting what? A probability plot. So you open your normal bracket, add your DF, open your square bracket, and let's call, okay, we're looking at income. So let's see income. So don't forget that you must have your, when it comes to this, so income, always forget that everything that has to do with character is what is being put into what? Into a inverted comma or what? Into a tag. Okay. So let's do drop. If there's nothing, if it's not available, you drop it. Or if not, it can execute. So let's go on. Then let's give it a distance. We're checking, what distance are we checking? We say we're checking normal distribution distance. So we just say distance is just the normal distribution distance. Let's call it norm. Norm. Looking for the normal distribution distance. And we'll tell it to plot. So you say plot. Your plot is equal to what? Your PLT. Okay. So now let's give it a title. Always remember that you have to give your plot a title. So PLT.title. Open your bracket and let's call it income QQ plot. Income quarter plot. Your Q plot. All right. We are good to go. Then the last thing I told you, when you're printing, for you to be able to print, you have to do what? PLT.show, so that your graph can what? Can be rendered. Okay. Then we'll say what? Print. Let's put a print word to be sure that if it is working fine, then we are good. So I just say what? QQ plot displayed. So let's do that. QQ plot displayed. And let's put a new line so that it looks very, very good. So let's run this and see what's going on. Can you see? This is our normal line of distribution. Can you see? This is a normal line. It's the normal line of distribution. But when you look at, can you see deviation? Can you see deviation? So you see why we say QQ plot. It's very good for you to know what is the level of deviation from the normal order of what? Order of distribution. So this thing shows you what your data, you can see the first one shows us it's rightly skewed. Now we can see where the deviation is. Can you see? Can you see this guy? Can you see how far this guy is away from everybody? Can you see outliers? Both to the negative and what? This is still okay, but look at this and this. All right. Then let's check for any numerical skew. Is there any numerical skew? Let's see if there's any numerical skew anywhere. Let's do that. So we'll just use, I said you just use Q underscore value is equal to what? DF dot skew. If you remembered, if you've checked the note, numerical skew. So it's good to always go back to our notes and watch our videos. There's a lot to always learn when we do that. Okay, so I'll just call the skew value and the skew underscore values. I want to see the values. I call it skew underscore values equals to what? Give it a df.skew, close brackets. And I tell you to print what? Print the skewness for each column. So let's print and see what's happening at each column. Print, let's open the skewness for each column. Let's try that. Skew for each column. Then comma, let's call our skew function, which we call skew values. Call this skew what? Values. Right. Let's open, let's give it that. And let me put a new line. All right, so let's print this and see what will happen. Okay. Could not convert strings to float. Low. So you see what's happening now? It has found out that what? There are some what? There are some strings that are not being converted. So you can see our error. Could not convert any string that you have to what? To a float. So you see, this is one of those things that you face when you have numerical skew. And there's a numerical skew. What does it mean? It means that what? Your some integers or some numbers are having what? Floats. So they are not taking what? They are not taking the same what? They are not having the same data type. So you are bound to what? To run into error. So let's leave this way. So this will be your assignment 1 for this class. How do you solve what? Numerical skew, so that you make sure that for this data set that you have created, how do you solve it so that this can be displayed? So I will leave this error for you, and that is your first class assignment. So you have to go back to what? You have to go back to your videos. It's so unfortunate that we have about just 4 minutes left. We have about 4 minutes left. We didn't start early. All right. So these are the little things I want to show. So for next class, when we meet on we are meeting today's Tuesday, right? So it means that we are meeting on Friday. We'll finish up our practicals. We'll finish up this practical. So what have we been able to do? Number one, because this is I've taught us how to import all libraries, which we've done that. We've created dummy data using what you call the random seed, which does what? It generates data on its own. All you need to do is set your number of instances, and you see, so you generate. Then we decided to generate some skewed income data. We did a normal age distribution. Then we tagged education as what? As low and medium, high, giving what? A categorical data. We added some missing values. We added outliers. Then we created a data frame for what? For our dummy data, which which we saw when we were able to run this. You saw what we got. So this was what we got. Then we did our histogram to see our level of skewness. You can see that this is right. This is a right what? A right skew. Because what? It's what? It is what? Tending to the right. If it's the left, then it goes this other way. Then we wanted to see our distribution using the QQ plot. What is the level of deviation from our distribution plane? You can see outliers, this. Then we try to check numerical skew, but we are having issue with what? With converting a what? Strings. So please, I'll need screenshots. What are you going to be sending to my email? You're going to be attachment to my email is what? A screenshot, or not even a screenshot, your Python code like this. Then solving this line, making sure that what? This line works, that has error. So you send to me on or before Friday. So this is the email you will send it to. I'll add the email there. I'll add the email. All right. So this is the email you'll be sending the assignment to. So next class when we meet, I'll make it a markdown so that, yes, it's printed well. Okay, so you're sending this to me. So I'm going to save this video, attach the video to our platform now for those of us that have that are already registered on our platform. So for the sake of Marian that is just coming in, I'll be stopping this class, and quickly I will stop the recording as well so that I can show you how to onboard you onto our platform. You don't have to use those folders anymore. All right, so let's stop the recording for now. I will share this video with you.